One is your issue related to structures, another one is the nature, another one is the future. So we have to construct the structure, and while constructing the structure we will utilize the materials or the things available in the nature, and all these constructions is for the needs. It's not only satisfy, or it will not only suffice the purpose of today's needs, it will also keep the requirement, or it will also be constructed in view of the requirement of the future. So the three aspects you will see, this nature was there, it is previously there, we are constructing the structures, and we have to give emphasis upon the future. So if there is not a balance between these three things, because you will tell that, sir, we will not disturb the nature, so then things are very good. If you will not disturb the nature, things are good, it's fine. But the construction is required. It is the need of the hour. You have to construct. You have to construct the road. You have to construct the building. You have to construct many things. Otherwise, the human beings or the society cannot serve the purpose, or it cannot use the utility of this. But if you will try to do some things that is little bit hazardous to the nature, so what will be the consequences? This is the very burning example. Uttarakasi, this tunnel failure. It's not like that. People are not constructing the tunnel. It's not like that. It is the first time construction. Tunnel was previously constructed. Tunnel is existing. Tunnel is performing. Many good tunnels you also know. But probably while constructing, because today's at this age, in 2000, we are in 2023. In this age, the technology is known to everybody, because with the help of these communications, your internet, many aspects, people are well connected around the globe. Whatever the technology is being developed in one corner of the world can easily be transferred to the other corner. So it's not like that coral provision is not known to them. It's not like that the workers, the technical community, the engineers, the policymakers, they are not aware about the fact of this tunnel issue. Everything was there, but there was some lacuna, maybe some failure, or some basic things that was not followed properly, which disturbed the nature, and we could understand that what is the consequences. It's thanks to Almighty that all the miners, those or all the workers, those who are trapped, they can easily come out. Otherwise, it will be a issue. It will be remembered till the end. But whatever science and technology will be there, we cannot give life to a person. So casualty, we cannot bear with this. We can recover our economy. We can recover many things. So if you think that what is the importance, that how can we recover our economy, you must know this US whenever they have dropped the atom bombs in Hiroshima and Nagasaki. After that, you understand how Japan has come back. What is the economy of Japan? What Japan is contributing to the world? So that's there. It's not like that. Economy can recover, but the casualty, the loss of a single life can, whatever technology is there. Corona has taught us a very good lesson. So all these things, we cannot stop construction. We have to construct. While constructing all these things, we must follow some basics or some ABCD of the construction, that we should maintain or we should meet what is the requirement of today. We should use the available resources consciously, and we should consider that material, whatever we are using, that should also be preserved for the future generations. So that is the whole basis, or that is known as the sustainability more technically. So if, as I have told you, that we should not destroy the nature, we should not disturb the nature. Yes, you should not disturb the nature. You can only utilize some of the resources, and if you do like that, there is much things that you are able to see. You tell that different wonders are, you are not able to see this. It's not like that Taj Mahal was built, where it was built that all the things was already there, people just came and connected it. It's not like that. They might have brought these marbles far away, 1,000 kilometers away from that place. The masons, the man force, the engineers, the technical persons, or that time the king, he is also away from some places. So there are so much of economy, so much of technology, they came, and now we are seeing this. So if you tell that we will not cut the marble from the mountain, it's not like that. You can do this, but you have to give some emphasis. You have to strike a balance between your structure, and you have to strike a balance between the natural resources. And you cannot, you have not the authority, you have not the permission to utilize all the resources. You have to keep something for your future generation. So it's a judicious utilization of the available resources and keeping the same thing for our coming generations. That is the whole issue of sustainability without any adverse effect to the environment. So now I will come that whenever we are constructing the things are so easy. So here I have given you some examples of the road networks. You can see that this one, it is constructed in a very plain area, the elevation is fine, so you don't have any problem. But whenever you are going for this Chennai bridge construction, you see what are the challenges the people might have faced, how they have to construct this on these different elevations. Again, whenever you are coming for the hill roads, you can understand what is the channel, or what is the challenges for the technical communities. Again, this was the example of the Bandra only sea link project. So here also it's not like that. You must have seen that if you are studying the survey or if you are doing for the bridge construction, it is the basic requirement that always they will find the alignment, it should be straight. In the case of, if you have gone through the survey paper for the bridge, for the road network, it is always the construction will be easier if you go straight. You can find an alignment which is straight, but it's not feasible always. They have to go like this. The roads are simply will see like that. It's just moving like a snake. So it's not easy to give that alignment. Similarly, the overbridges, the Bandra sea link, it is not completely straight. And the Chennai bridge, the height difference is different. So in that case, for one abutment, one pier, all are not of equal length. So in that case, you have to take the help of the technology. You have to construct it judiciously. Otherwise, it will be not successful. Then, if you are telling that we have to use the natural available resources judiciously, we don't have the permission to use all the resources, we have to think about the future generations, then what we can do? We cannot stop construction, because you understand that what is the infrastructural growth the India is having, how much road network is being constructed, how much railway network is constructed day by day, or every year. You must know that we are having new airports, and that's the need of the hour. People can't spend the time by traveling through the train, they can't spend the time by traveling through road network. People can go through air so that they can reduce the time. So if our construction is the necessity for the mankind, or for this country like India, not only the India, many of the countries. So I am not using the word that developing countries. How many days we will use the word as developing country when we will be developed? It's not like that. We are not in that. We are much ahead of that pace in the construction sector. So natural resources, it is limited. So what we have to think? We have to think some alternatives. What can be the alternatives? Look here, there are these type of different type of wastes are being generated daily, from the construction side, from the agriculture, even from your domestic kitchen waste. Many waste are there. Factory, biomedical waste. What is the importance of biomedical waste? You understand during the COVID time. This PPE kit, this face mask, how much? We'll discuss in subsequent slides. Similarly, there is some nuclear waste. So if you will go for the uranium mines, there people will tell that, okay, there is a radiation. Many things are there. The people does not understand what is the issue, but there will be propaganda. So people will say, no, there is some radioactive things, we will not use it. It's not like that. If the technology will be there, we can try to use this waste. Then what will happen? One, it will be a win-win situation for the utilization, waste utilization, because the disposal is an issue. Whenever you are procuring, suppose face mask during the corona times, you are wearing, you are keeping yourself safe, but you don't understand that once I can't use it for its lifespan is not that it will be for a long time. You can use it after some days, after 2-3 days, after 1 day, you have to throw it out. Where it will throw? It's not like that you are the only person. You understand what is the population of the India. So if all the people will try to throw, what will happen? So while purchasing, while using, we don't understand that what will be consequence whenever its expiry will be there, or whenever it will be, the use will be over. So what will happen to that? Where will throw? It's sufficient land is not there. You will go and throw it there. So in that time, what will happen? We have to think the alternative. Can we recycle it? Can we reuse it? Can we recover something from that waste we are throwing? So the best alternatives or the best applications is given by the civil engineers like you, including me. I am also a civil engineer. So what we can do? There is a Brahmastra with us. What is that? That Brahmastra is concrete. You know what is the requirement of concrete, or what is the construction, or what is the contribution of this concrete to today's infrastructure? You must know. So if to some extent we can use this waste in the concrete, the constructions. So first of all, think that waste utilization will be there. The construction cost will be reduced. Then there will be no requirement of landfill, or there will be economy will be very much reduced. So it will be a win-win situation, both the waste utilization and the economical aspects. So while considering all these issues, we must consider the aspect of the sustainability. What will be that? Whenever you are considering sustainability, it is the judicious utilization of natural resources without adverse effect to the economy. And the technology you are giving, it should not be a difficult one, that people will not accept it. So if it will tell that it will be used in concrete, people can easily use it, because if you go to your village, if you go to any rural areas, I am not differentiating with rural and urban. I am telling that in case of the urban, the technology may be much advanced. Okay. So in case of rural, in some corner, some part of India, still electricity is a dream there. So in that aspect, if you go there, technology may not be there. Some of the people, they may not be aware about the technology, but still they are using concrete. So what is the wide application of the concrete, you know? So in that case, if we suggest them, look here, we can utilize this in the concrete. So whenever talk about the concrete, what is concrete? Simply you know that it's a not a simple mixture. It is a proper designed mixture with cement, your coarse aggregate, your fine aggregate, your water, the minimum constituents of concrete. Then you can add any chemical admixture like super plasticizer or water reducing admixtures, or any mineral admixture like fly ash, slag, GGBS, different things. But the minimum requirement or minimum constituent, basic minimum constituents of concrete is your cement, coarse aggregate, fine aggregate, and water. So if this waste can be converted to the constituents of the concrete, then it will be very good. So what is the feasibility? One thing is that if you have constructed, or if you have tested some properties of concrete, or if you have gone for the mixed DNA concrete, I am sure that your professor must have taught you that in concrete around 70 to 80% volume is being occupied by aggregate, fine aggregate and coarse aggregate. So if we can, because the optimum utilization will be there whenever we will target to the maximum volume. So if this can be replaceable with that, or this can be added to some extent, then there will be a very good utilization of this waste, or effective utilization of the waste, and this waste will now converted into wealth. And there are different slogans like your Swachh Bharat, waste to wealth. Many issues are there. Some issue definitely will be achieved. So whenever we will go for this infrastructure, that is sustainable infrastructure, so in that case, what will happen? In the sustainable infrastructure, there will be two issues. One may be energy related issue, another one may be material related issues. Am I audible now? Hello? Hello?
Yes, sir.
Yes,
Are
sir.
you?
Okay. So sometimes you may stop me. If you have any doubt, you can stop me. So energy related issues and material related issues. So I will talk about the issue, most of the issues related to the material. Okay. I will not go into the issue related to the energy. I think that that's not my cup of tea. So whenever any material is being produced, either the natural material, because even if the rocks are available, we have to go for the conversion into coarse aggregate, because proper size will be required. You will tell me that, sir, there will be grading curve, there will be geometry, there will be different physico-chemical aspects. Yes, that should be satisfied, but you are going to convert this. It is not completely available. Okay, so you have to get the proper size of the coarse aggregate. Fine aggregate is available in the river, so it's not always that all the cases the fine aggregate is available. Sometimes the stone is converted to the fine aggregates. So in that case, you are utilizing this as construction material. Then a structure being constructed, it's not like that it will be, there will be no expiry date, there will be no life cycle, that it will be constructed till the end of the human being, mankind, it will be there. No, there is some life cycle. Suppose a building is constructed, maybe 60-70 years it must be repaired so that it can perform. Some of the bridges, you must know that it should be demolished and it can go for the new one. Construction structure, many aspects that can be demolished. Road network may be demolished and for newer, because the material that you has proper life cycle. And requirement is there. Previously, you have constructed 10 years before a road. You are constructing that load will be this one. The load will be 5 tons. But nowadays, after 10 years, you can understand that no. The load will be now more, 20 tons. So in that case, that material may not be effectively suffice the purpose for which it is being constructed. So in that case, the degradation of the strength of the materials, or degradation of the material properties, or requirement, or the new requirement leads for the demolition of that structures. So if the structure will be demolished, what will happen? If the structure will be demolished, what will happen? It will lead to product some waste. It will lead some adverse impact on the environment. So what we can do? As I have told you that we can use it in the place of concretes. Now in today's presentation, I will show you different type of demolition waste, different type of waste, and how it is being used in concrete. Okay. So these are the construction and demolition waste being generated from different type of construction sector, like buildings, like bridges, like roads. So around 14.5 million tons. Now the amount may be more. It was little bit less or 2-3 years before I have taken the data. So now it is around 14.5 million tons of demolition waste is being produced every year. So what we can do, if we reuse it, recycle it, our natural resources that will be preserved, and the energy consumptions for production of the aggregate or sand that we are doing for the natural things that will be reduced. Then whenever we are having this waste being generated, so some of the municipality must have rules that you cannot dump it on the road. You have to remove it, otherwise they will come and give a bill that this much of fine you have to pay. So where to dispose it? So if you can recycle it, if you can reuse it, then it will be a win-win situation. Then economy will be achieved definitely. So now, if we'll go for this requirement that which type of metal we'll try to use, you can know that what is the requirement of this. I have maintained up to 2020. Now it has been something more for the construction sector: sand, soil, stone aggregates, and limestones. So I can have the options that sand can be replaced from the C&D waste. I can have options instead of soil, we will use fly ash. Instead of stone, we can use construction and demolition waste. The C&D waste is construction and demolition waste. Limestone, we can use the fly ash. So that way, the sustainability will be achieved. And if you are using 1000 kg of recycled aggregates, you are saving around 8 kg of carbon dioxide. So you must understand what is the importance of saving of this carbon dioxide. These are the different form of the how the construction and demolition waste are there, different type, from the soil extraction, road work, demolition waste, and other waste. And this is the percentage of or different constituents of the C&D waste, that it constitutes this brick and masonry waste, metal waste, wood waste, soil, sand and gravel, bitumen, concrete. So comparison to India, some of the other countries like US, UK, they have much utilization of this recycled waste. In case of India, it's negligible. In fact, you will find compared to them, it's simply zero. So where we will get this waste? Different type of waste I'll discuss. First one, I am talking about the construction and demolition waste. Then I will talk to different type of waste. How I will give you some glimpses, some idea that how you can utilize it in the concrete. Fine. So first type is C&D waste. Where we are getting? We are getting, as I have told you, we are getting from the demolition of the buildings. This is recycled concrete aggregate. We are also getting it from this main resource is from the road network, that is recycled asphalt pavement. So if you are getting this, what should be its destination? The destination, most of the cases will be, it can be used as the base material. It may be placed at the landfill. It can use at the PCC. Similarly, in the case of other that recycle asphalt pavement, it can also used as a landfill, base material, like this. So this is the picture showing that what is recycled asphalt paving. Many of the time, whenever you are moving through the NH or any state highways, you must have seen that they are just getting it out and giving it a new layer. So in that case, this is the recycled coarse aggregate before processing. This is recycled asphalt pavement where bituminous mix will be there before processing, and they have now converted it to the coarse aggregate. I'll comment this. It has been recycled asphalt pavement is being converted to coarse aggregate. So recycled coarse aggregate is converted to recycled coarse aggregate before processing, that we are getting from the big chunks. And recycled asphalt pavement, it is the issue with attached to the road with layer of the bituminous. So that is also converted to recycled asphalt after the processing. So it's in your mind that what is a construction and demolition waste? This you must have seen these big chunks while demolition of the buildings. And this is simply a jaw crusher. So the just like you know that the crushers are using for the crushing of this rice, crushing of the you are using these millets, all these things. Similarly, it is a crusher that instead of a big crusher, it is a small one, so you can put it there. And whenever you are using this in the case of the aggregates, you know that these are the guidelines which must be satisfied related to the size. So you will sieve it and accordingly you can get it. And here is the options that you can give, that I will get this much range. Range you can fix it. From the big one, it can convert it to these 3 sizes. And whenever you are talking about the use of this recycle aggregate, so it's a question that if you are going for the natural aggregate and what is the economy. I have just shown you one sample case. So here the economy is that around 15.5% is achieved per meter cube of the concrete construction instead of natural aggregate if you are going for the recycle aggregate. So if economy is not achieved, people will not accept it. Understand? This is one sample case. Other case also you can see. So there is the options that whenever it is a recycled coarse aggregate, we can use it as base, subbase coarse, surface coarse. If you have studied your transportation engineering, the pavement engineering, you must know this. And recycle asphalt pavement, you can also use it as a base, subbase, and the soldier of the road. So this is the flexible pavement. The top one recycle coarse aggregate, and the other one is the rigid pavement. Okay. So that is one type of waste. Now I am showing you another type of waste. As I have told you, I will show you what is the feasibility of different type of waste utilization in the infrastructure. Okay. So this is, you must know, this is waste tire. Now this waste tire can be converted. It can be converted from this waste tire. There is a steel. You must know that the steel fibers are there, which is holding this tire. So you can convert it to steel fiber. You can convert it, this waste fiber, to aggregates. Sorry, waste tire into aggregates. So you can also use it as a coarse aggregate. Okay, or steel fibers. You know that what is the importance of fiber in concrete. To improve the tensile strength, we use the reinforcement. Instead of that, you can also use the fibers. So if you go for the purchasing of the new fibers, it may be costly, but if it is a recycled fiber from the tire waste, definitely it will be economical. And this is another issue. So if you can see that this issue, you must have seen this nowadays, the plastic waste in different forms. In the sea, the PET bottles, soft drink bottles, the polyethylenes, many things are there. And this is a very buzzing issue in the cities, and it is headache for the technical community. Many a times there is, wherever you will go and you have to dump it, the locality, the people will oppose. They will tell that no, it cannot be dumped. And if you go to fire it, it will create so much of pollution with very bad releasing of the different type of harmful gases, and it will create nuisance. So how to handle it? And you can understand that if you go to ocean, you can see this. These polyethylenes are there. We are using this in the ocean. We are just throwing it, and they are telling that if you will not go for the proper utilization, proper management, so in 2050 there will be more fish, there will be less fish in the ocean and more plastic. Okay, so you have to go for that. And this is a data published by India Today. But what will be the requirement or plastic uses in 2050? So it is that we, for India, we will go for 4 times whatever we are requiring now. In 2050 we will go for the use of 4 times, around 160 million tons, whereas requirement for the United States is 165 and China is 203. So can you understand what will be the consequences and what will be this waste generated? Because you cannot stop the use of plastic in our life. The milk packet you are using, you can't stop. Whenever we are telling about the plastic, you are telling that polyethylene. You can stop the polythene. Fine. What about the milk packets? What about the PET bottles? Many plastic in many forms are available in our day-to-day activities. We can't keep away from it, but its effective utilization will be a blessings for the mankind, and it will lead to a sustainable future. So if you go see, I am not going in detail for this. what are different states of India with respect to its population, with respect to its economy, they are generating the plastic waste. And who is leading this one? Maharashtra is leading this one, 13%. It is the data with respect to 2022. Maharashtra is leading 13%. Then Tamil Nadu and Gujarat. So we can stop it, but we can, if judiciously we can use it in the infrastructure development, then it will be blessings. Now different type of plastics are there. I am not going through this. This is two types, thermoplastic, thermosets, because we have to understand what is the nature, how it is being generated, the plastics, and what is the total plastic waste productions. It is around, whatever we are using total production, plastic waste is around 80%. Only 9% is being recycled, and around 79% are going to the landfill and environment. So in that case, it is a issue, or it is a matter that the technical community and policymakers must think about this. This is the plastic waste generations in the million metric tons by Central Pollution Control Board. Okay, so around 5%, around 6% of plastic waste generated compared to the municipal wastes. So this is the state-wise plastic waste generation or contribution, and how to go for the plastic recycling chain. So we have to, if you use it, we have to go and collect it. Manual sorting. Manual sorting means it is not like that people will keep the plastic waste for you. It will be mixed with other materials. So that plastic PET bottles you are throwing it, it may contaminate or it may be attached with soil. So you have to go for segregating it. Then you will go for screening. Then you will go for size reduction, washing. Then you can tell that, okay, this is only separated plastic one. You can take it and use it. So these are the different type of recycling process. I am not going into that. We will show how we are using it. So as I have told you, it is always a challenge with respect to different type of plastic separations. It's low density plastic, high density plastic, polypropylene, polyethylene separations, and with respect to color, there is also problem. And with respect to the type, whether you are using in the surface or you are using the marines, that is also an issue. So it's not like that people have not worked. A person known as Rajagopalan Basudevan, he has used this plastic waste in the construction of roads. So, and he was awarded with Padma Shri. And this is a plastic brick, recycled plastic brick. So you are using this clay brick and fly ash bricks. It can be an alternative to that. And if we will go for the use of this plastic in concrete, what will be that? In which form? As I have told you, that we can replace it in the form of coarse aggregate and fine aggregate. This is from the PET bottle being converted to the fine aggregates. So this is with different sizes, people, and with different substitutions by volume, people have tried. This is, you must have seen that this type of tray. This is used for the, in case of fruit market, in case of fish transportations. So you can convert this to the plastic aggregate also, plastic coarse aggregate, and the replacement is being shown. And look here, whenever you are converting it, you must go for the physico-mechanical characterization. It's not like that you will convert it, get the size, and you will go use it. You have to go for the physico-mechanical characterization. It's sieve analysis, it's water absorption, your the impact, the crushing, like that, different aspects, impact, crushing, or abrasion value, all these things type of test, like coarse aggregate. Similarly, the test for the fine aggregates, if you are converting, you have to check it, the physico-mechanical property, otherwise you can't use it. And this is, nowadays these compact discs are obsolete, but still then if it is available, you can use this compact disc as the aggregate through. Okay, and this is being used as the fine aggregate. Okay, and different percentage of substitution people have tried. And this is the cover of the PET bottles. You can use as coarse aggregate. This is the Coarse aggregate, I have told you this compact disc as fine aggregate. This compact disc can also be used as the coarse aggregates. The sieve analysis is shown here. You know that anything more than 4.75 known as coarse and less than 4.75 is categorized as fine aggregate as per Indian standards 383. This is some of the crushed PET bottles. It has been converted to the plastic aggregates. Okay, so this is the aggregate recycled aggregate, and this is the plastic aggregates. So you can also add it and you can use it. And this is with respect to the e-plastics. What is e-plastics? You are now I'm presenting in a PC. So the desktop is there. After sometimes it will be damaged. It will be it will be not useful. The CPU is there. It will not be useful. That is known as e-plastic or e-waste. You can also use it as coarse aggregate. Cross it and you can use it. And different type of glass. So waste glass, that can also be used as the fine aggregate. And whenever you are using it, I will tell you in physico-mechanical characterization, you also include its basic property that anything fulfilling the size requirement cannot be added as the concrete, because you must know what is its chemical composition. Like you can go for the XRF, you know this microstructure analysis, XRF to know the chemical composition, because whenever we are adding water to the different constituents of concrete, there is proper bonding, there is some chemical process going on. You must know water is added to cement, heat of hydration is being released, some chemical reaction is going on, then they are going for the, or they are contributing towards strength. So if the chemical composition is not fine, they cannot contribute towards the strength, and simply addition will not be effective or will not be suffice the purpose for which it is being used. So you have to go for the XRF. After that you have to go for the XRD analysis, FESM analysis, the microstructure analysis. What is the mechanism behind that, so that we are getting this much of strength or strength is being reduced. This is different municipal solid waste that is being produced. So around here you can see that 13% is the plastic waste. So during the time of COVID, so this is the things that saved us, the PPE kits, different forms, the face mask, gloves, face shield, shoe cover, body overall cover. But what is the consequences? What is the waste generated? Millions of tons of waste are generated from this COVID. Where we will keep it? Where will we dispose it? Should we throw it in the ocean? So if you throw it in the ocean, if you dispose in the ocean, what will happen to the water bodies? If we place in the land, so people will tell that there will be some negative aspect on the human health. So what will happen? And even if Corona has gone, COVID has gone, but still then the peoples associated with medicals, healthcare units, they are using this one. So what will happen to that disposal? Is there any opportunity that we can use it? Yes, there is the opportunity. There is challenges. Challenges will be there. Whenever there will be challenges, engineers, technical community come, they will sort out a way. If there is a will, there is a way. So people will come, people will try to utilize it. How they will utilize? So there will be some infections, they have the questions. They will try to use some decontamination process so that the infection or the issue related to the virus will be reduced, or it will be not there. After that, you can go and use it in concrete. So what are the options? The nitrile gloves can be tried in concrete. Face mask, PPE kit, this is for the concrete. You can also use in the pavement. You can also use in the soil stabilization, the face mask. People have tried, different researchers, but the study is not complete. You can go and do a systematic study with this. And we at IITSM, we are also doing something with my research class. They are doing these plastic bottles, because they are telling that if I am telling something, I should practice it. Yes, we are practicing something. The PET bottles, we are converting it to PET fibers. The PP band, you must know these cartoon striping bands or cartoon packaging bands. It is a PP fiber converted. And nylon fibers, it is from the net, the fishing nets, and it is known as a textile waste too, nylon some fiber. Coir fiber, you must know the coconut, this is that fiber. So all these issues we have studied not only in concrete but in the building constructions, but in the case of the mortar we have utilized it. I will focus my some of the presentation will related to the PET fiber, plastic waste fiber. These PET bottles you must know, soft drink bottles we are converting into the PET fibers. So how we are using it in the buildings. So now you can see this is a masonry buildings, one-story buildings, scale down models, and this is a sectable for the seismic aspect. We have used this in the case of the joint, that bed joint, head joint. Bed joint means you know that between the two brick layers it is known as the bed joint, okay, and between the two bricks it is known as the head joint. There we have used, and then we have gone for the plastering too. So you will tell that, sir, how you have used. Yes, we have gone, whenever we are adding in the mortar, we have gone some basic test, we have tried to optimize it, because the balance between the strength and the balance between the workability, because it is not easy if you add the fiber and to work with that, it is not easy. Plastering will not be easy process. So people ask that, sir, what will be the bonding issue, because plastic don't have any bonding between the concrete. Whenever you are doing anything, you should be ready to answer many fundamental questions. People will ask, because whatever may be the things, the basics will not change. Okay, so we have also gone through all the type of bond test, strength test, everything, and see we have given up shaking. You can see the failure things due to the presence of the fiber, due to the fiber bridging mechanism, it has not completely collapsed. And if there is not proper bonding, whenever we are shaking it, the plastering will come out. It has not come out. It is a proper failure has been shown. So it is also effective. And this is a more clarified way or more zoom way. I have shown you how it is there in different type of, still the building is there, because there is some mechanism, fiber mechanism, it will not try to detach the things, and the complete collapse is being avoided, or lateral stage it will be collapsed, so it will give the strength. It is effective seismic strengthening. Okay, so now come to my end of these things, my presentation. So what I have told you, I have simply told you that there are different options engineers can try with the different waste, the effective utilization of the natural resources with the optimum utilization of the waste, that will construct our infrastructure, our structure, which will lead to a better future. I will be happy to answer the questions if any, please. I have